Hello Nexters, welcome to Whiteboard Wednesday. It's live. What could possibly go wrong? I could walk out of frame, for instance. Today we're doing alpha channels. What's key? You see what I did there? That's a little joke. What's key? That's a technical joke, but I guess we'll get to that. So we're going to talk all about alpha channels. So let's just get on with it, shall we? So let's define what an alpha channel actually is. So an alpha channel is effectively a key. And a key meaning key and fill, etc., etc., etc. So let's just punch up here this ball. Now this ball is over the top of what you can see here is a football pitch. Now these are two actual separate images. They're not the same image. They're two separate images. And one is keyed over the other one. Now that in its own right has a fundamental issue around it. So let's just look at that a little bit here. So here we have, for instance, the ball. We're on the black background, and the ball itself here is just spinning away, and here is the grass. And if I was to bring the ball over the grass, we're going to have one fundamental problem here, which is that the black background covers up the grass. Okay, so what we need to do is we need to make some kind of keyhole to get rid of that. So let's break this up and show you how that works. So this is what we would call the alpha. So this is a keyhole. I think of it like looking through a keyhole. And what this will do is cut a hole in the grass to see the football. So it's actually a strange concept, but actually let me show you. If I just bring up the alpha really big here, so here's the alpha for the football. And if we look at the grass here, it cuts a hole in the grass. So the football is actually behind the grass. It's not actually on top of the grass. We've cut a hole in the grass to show the football inside. So the football's actually behind it. And that's how key and fill works. It punches a keyhole through a piece of video to put another piece of video on top and composite it in all intents and purposes. So there's three types of key. There is luma key, chroma key, and linear key. Let's take the first one first, luma key. I'm going to use a bit of an After Effects video here just to show you this. So this is a luma key here in the effects. Luma key works on the brightness of the picture. So when I start to take the threshold down on here, we'll take away the brighter parts of the picture and add the key. So the grass comes in where the bright parts are. Now in this case, this is almost completely useless because there's such a variation in tone here. But things like text, logos, stuff like that, you can actually do very well with luma keys. So let's move on to the chroma key. So this is inside After Effects. There's a thing called keylight, which is a chroma keyer. What we do is we'll just pick the blue color. Could be a green screen, right? Same concept. And you see instantly it keys. It's a little rough down here because we've got lighter shades of blue. But what we can do is we can change the screen gain and the screen balance a little bit. And now you can see that that's changed there. And now we have almost a perfect key. The hair's not right. There are little bits and pieces that you have to do around that. But that can work really nicely. So I think here we play around with some softness inside the mask and stuff like that. And the final one is a linear key. So in this case, what I'm going to do is actually, I'm just going to hide everything so you just see the transparency. Okay, so now it's just transparent. Okay, and then bring up this text that says World Cup here. Okay, so if I actually look at the alpha channel only, so here we're just looking for the alpha channel. You see, a lot like that football, it's just black and white text. So if we go back onto the RGB now, and there we go. And we turn all the layers on, turn the text off, but we allocate for the girl that the text will use the alpha channel. The girl will use the alpha channel from the text. So the text cuts the hole, and then we see the girl through the linear key that's been punched through the grass. And of course, the layer underneath of the girl here, we can actually take that, and if we want to, we can actually move that around and reposition that to get much better effect like that. You see, we can even slide it left and right. Of course, we hit the edge of the image, but then you get like a wipe effect, right? So it's kind of a similar thing. Okay, so here I say that little bits that count. I've had a lot of fun playing around with the words bits and bytes and stuff like that with this. So it takes 3 bytes, 3 times 8, 24 bits to represent a single spot of color. This is very technical, bear with me. So I'm real pun on words here. In 1984, the bit when I was young, it was a bit. So it was either on or off. So whether you had a ZX81 or like at school we had these Commodore PETs where it was green, so the CRT was green, so obviously when the pixel was on it was green, whereas on a ZX81 the pixel was on it was black or white, right? So, but it's a single bit. It's either 1 or 0. So that is basically what a bit is. The more bits you have to describe that pixel means that you can start to add on color to that information. So we started out quite a while back actually at 8-bit, but I've skipped that bit. But I've skipped that bit. You see what I did there? I've skipped the 8-bit. So it's a 16-bit color. 16-bit color is each component or each pixel basically has 5 bits to describe it. And you end up with about 65,000 colors, which is a lot of colors. But it's still less than the human eye can actually see. So you'd have dithering and stuff like that in it. Then we got to 24-bit color, and 24-bit color we were using 8 bits per pixel, and that's 16 million colors. So that's an awful lot of colors. So of course the quality improved greatly when we're using 24-bit. Now neither 16-bit, 8-bit, or 24-bit had any alpha. Now, you could argue that with 16-bit, there's 5 bits assigned plus 1 unused bit that you could use for transparency, but that's a whole other argument. But basically, you didn't really have any alphas with 8, 16, or 24-bit. So when we got to 32-bit, we basically just said that's 24-bit plus an 8-bit alpha channel. And the reason that you have an 8-bit and not a 24-bit alpha channel is because when you're doing grays, so the pixels in the alpha channel is either black for transparent or white for solid, or the other way around, depending on how you interpret it. And, but you don't need so many of them because you're only using a grayscale. So you've got all the shades in between is the transparency ramp. So that's why it's only 8-bit. So most stuff these days actually is in 32-bit. Things have moved up a bit to 64-bit color, where you've got 16 bits per channel. That gives you over 2 trillion colors. Why would you want 2 trillion colors? Well, because if you want smooth gradients, particularly when you get into the world of Ultra HD or 4K, and you need really smooth gradients, then you need to use colors that even the human eye has trouble seeing, as an individual, but you have beautiful sweeps of color that you can achieve using 64-bit. So now I'm going to do a little demonstration. There's not only all this bitrate stuff, you've also got this thing about pre-multiplied and straight. Okay, so the straight alpha is effectively the linear key that I showed you earlier with the text. Pre-multiplied, slightly different beast. So I always say step away from the dark side. Let me explain. So I've got another little After Effects video here to try to help you understand this. So this is the straight alpha that we're going to see here, and that's the ink. Okay, so this is just a straight alpha. It's just, at the moment I haven't got the alphas on, so it's all black. And then over here, I've got this kind of swirling, and this is a pre-multiplied alpha, okay? So there's nothing to see here, right? This is just the same kind of stuff. Let's turn the transparency on. Now let's look at with the key running. Now, this is interesting. Here, it's a little muddy, but here, this is perfect. It's absolutely perfect. The question is, what's going on? So why don't we go all the way back to my straight alpha here, and we'll turn the key on, and you can see it has this sort of fringe that's slightly black all the way around the edges of it. And that's because the background is black, okay? So if we switch to the actual alpha channel to see that, we can do that here. Yes, here we go, alpha channel. You can see that the grays that we're cutting out is also cutting out the black background from the RGB. So we actually get a bit of black fringing inside of here. So this is a straight alpha that you're actually pulling it off of that background. So now let's try and look at, go back to the RGB, Adam. There we go. Okay, let's look at the pre-multiplied. So here on the pre-multiplied, if we look at it on the black, for instance, it still looks perfect, okay? But the interesting thing, it looks perfect here. Why is that? If we go to the RGB straight, look what happens. You never show the client the straight. We fill in all of the colors as part of that gradient so that when the alpha channel, if we go back to the alpha, when the alpha cuts out here, it cuts out from the correct colors in what we call the straight channel, where it's filled in all of these colors here. So you never show the client the straight because they panic when you show them that. And then you get this beautiful gradient that's absolutely perfect on whatever you put it on, because it's actually cut out of the colors that was living beneath it. So that's pre-multiplied versus straight. Bringing it all together in a codec, okay, we have, this is the actual panel from After Effects, and quite a few people make a common mistake. They don't actually render RGB and alpha, they just render RGB, and then they don't know why it doesn't key. You actually have to tell systems that they have to render out the alphas, and also the millions of colors plus, because you need the millions of colors plus the 8-bit alpha channel, right? So that's why. And then here we select whether it's pre-multiplied or straight, okay? Sometimes that's referred to as matted. And the interesting thing here is that I'm actually using an Apple ProRes 4444 codec, 4444. That's a whole other ballgame. But these are all the codecs that support alpha, okay? I'm sorry, my name's covering some of that up. Just to make this a bit easier, the blue ones here are very, very, very common. So it's quite common to use the Apple Animation codec, which is otherwise known as uncompressed, and the Apple ProRes 444, the reason being that they support an 8-bit and a 16-bit alpha channel. So you can export a piece of video with an alpha channel straight out in those codecs, and you'll be able to overlay it in systems. It will be that, a graphics system or a character generator, whatever. The teal coloured ones here, these are actually what we call image sequences. So they're actual individual images. So if you run something at 30 frames per second, you will have 30 files, effectively, that is each frame of the animation. And you put them into something like After Effects, and then you can scrub through them. And it's a bit like a flick book, right? So when you flick that book and the tortoise starts running, it's a similar concept. The beautiful thing about image sequences are, if you want to change something right in the middle, you don't have to re-render the whole file. You could just render those out and then throw away those images and put in the new images in the sequence. And so you can actually, it's much easier to get into little bits like that. There's also the ability with TIFF files to run 32-bit alpha channels. And that's more for the coming. So FFV we've used in Next quite a lot. It's quite nice. There's the AV1, which is the open source. We don't know quite how that's going to work, but there is apparently some support coming for alpha there. JPEG XL, which is a huge thing that's coming now, and that also supports alpha. And also H.265 or HEVC, whichever way you say, or VVC, also supports an alpha as well. So that's not being used in a huge amount of systems right now, but it can be done. So that is everything I've got on alpha for you today. If you have any questions, I'm just going to have a quick look and see if anybody's asked any questions in here. Not that I can see. Although last time, I have to say, somebody asked a question, and it wasn't in my live stream thing. So I'll just check in LinkedIn. 1 second, everybody. There we go. I'm the worst host in the world. It doesn't look like it. And if somebody has asked a question, I'm sorry, I'll try and chase it up later. Okay, I hope that was all of value to you. And I'll see you next Wednesday. I'm off to Amsterdam today to do a presentation. And then I'm going to bring the presentation back here next week to show you, because that's going to be quite exciting. It's